All right, we're looking at proving triangles are similar. So the two new things we're learning that you probably want to put in your Paschal's theorem sheet is side-side-side similarity theorem. If the corresponding sides of triangles are proportional, then the triangles are similar. And side-angle-side similarity. If the angle of one triangle is congruent to the angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. Okay, so we're going to use different ones of these to prove it. All right, so if we're looking at part A, which is these first three up here, do we have any angles?
Nope.
So we probably want to use side, 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 right? So we have to figure out which ones are proportional. So I'm going to look at this one and the little one. And those two sides I'm going to look at first. Is 2 over 8, what does that reduce to? 1 over 4. Okay. Now let's look at a different side on the same triangle. Do you see how these two are corresponding? Okay, so 14 over 20, what does that reduce to? How many times does 2 go into 14? 7 times. How many times does 2 go into 10? Is 7/10 and 1/4 the same thing?
No.
No, so those aren't proportional. Okay, so now let's look at this big one and this one over here. So 6.4 over 8, and this is where we need the calculator. I can't do the Okay, so we've got 6.4 divided by 8 gives me 0.8. So let's try another side. How about AC and GI? 16 over 20. That is 0.8. Okay, one more side to make sure. We've got 13.6 over 17. And we've got 0.8. So we know triangle ABC is similar to triangle GHI. Pretty simple? Yeah.
Yes.
Okay, let's move on to B. Huh? I divided. Yeah. Okay, let's look at the next one. Okay. We're looking at this first 3 above the black line right there. So, what do you think we're using? Side, 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 or side, angle, side?
Side.
Okay, well, they all have a 90-degree angle, so I know I'm good there. So I've got to decide if one of the sides are proportional. So let's try the little one and the biggest one together. 3 over 7.5. Let's reduce that. Let's just divide and see what we get. 3 divided by 7.5 gives me 0.4. Okay, now let's look at 4 over 10 and see if we get the same thing. And we do. So we know triangle ZYX is similar to triangle CBA. You guys get the point?
Will they ever all be similar? So you don't have to.
Well, let's look at C.
So
All these triangles are what?
Yeah.
If you have a 60-degree angle, you know all of them have to be 60 degrees, right?
Yeah.
We know these two both have to be 60 because these sides are the same, so we know from base angle theorem. We know all of these angles are 60. If all the sides of a triangle are the same, that means all the angles are the same. And 3 divided by 180 is 60. So what do we think about these? These are all what kind of triangle, Nathan?
Awesome.
And equilateral, we call them. And all equilateral triangles are similar to each other. So we can say triangle XWL is similar to triangle MLN, which is similar to triangle BAEAC. Nathan, do you have a question?
Yeah.
Yeah.
B, what about that other?
You could try it, but it's not because I've done it before. Alright. Let's turn it over. So, yes.
Okay, so for this one, like the 2 triangles is the outer one and the inner one, right? Because I was so confused.
Yes.
Those 2 have been changed.
No, outer one, inner one. So So it's this one,
Yeah.
and then it's this one. Okay. So we want to see if these two triangles are similar. So I'm going to do the red one over the blue one. And I know this is going to be what? Is this going to be side, side, side similarity, or is this going to be
Side, side.
side, angle, side? And how do we know that?
Because there's a right there.
Okay. I know that the red one is what?
Number.
What is this bottom from C to T?
20.
No, T to T, not 8.
16.
Correct. And I know it's 16 because this length is 4. And I want to see if these two are the same. So I take 12.8. So pretty easy, right? You're basically just dividing and saying that you're getting the same thing. You could have reduced the fraction instead, but I find it hard to reduce fractions when there's a decimal. So we know those are similar, so we write a similarity statement. Triangle BAC is similar to triangle STC. Should I keep going or are we okay? Yes, Brianna, do you have a question before I move on? Okay, because you put, in this case, I put the little one over the big one. Okay? And the little side from T to C, I know A to C is 20, and I know A to T is 4. Do you see that? This is 20, but this little part right here is 4. So 20 minus 4 is 16. That's how I got it. Okay, does anybody want to do B or C, or we feel okay about this?
You see. Yeah, do
Do
B.
C?
No, B look hard. B look hard.
Do
B and C.
We'll vote. Which one do you want me to do, B or C?
B.
Raise your hand. Raise your hand if you want me to do B. Raise your hand if you want me to do C. All right, B wins. Okay. So first of all, we have two parallel lines cut by a transversal, right? So we know these angles are the same, right? Therefore, we can do side, angle, side.
Yeah, because the vertical.
Yeah. Oh, no, we don't want to do alternate interior. We want to do corresponding angles. Okay. So, therefore, we've got 7.5 over 9 equals 12 over 10. See? Again, just the fractions, divide. Again, you can reduce them instead, but I have a hard time reducing when there's decimals. I'm going to do it this way. Are they similar?
No.
No.
That's 10 and 12 in the wrong place.
10 and 12 are in the wrong place. They should be flipped. I know, man.
How can you tell them
It
if
is.
it's flipped or not? How can you tell them if it's flipped or not?
How did you know,
small or
Eric?
big?
What was the easiest way?
Well, because 7.
Because I had the small one and the big one, and then I had the big one and the small one.
Yeah.
So it messed me up. So triangle MNL is similar to triangle KLJ. All right, let's move on. Again, I'm going to give you 6.5 example 1 as extra credit. I told you, all proofs are going to be extra credit and none of them are going to be on the test quiz, so I don't want to hear any complaints. Because I can make proofs required if you want.
So we should prove on the test or no?
Stop talking more proofs, everybody, please.
Okay. How do we find H for this? We know these two triangles are similar by what? Look at them. How do you know?
Right.
Not all right triangles are similar.
Well, we have two angles that are congruent.
Two angles that are congruent, so we know angle, angle. So we can prove what H is by saying 6.5 over 91 equals 5 over H, and we simply cross multiply. 6.5 H equals 91 times 5,
It's
455. Divide that by 6.5. H is 70. Okay, let's do the next one. before, I went really fast. So, you guys got any questions about A? I went really fast. You sure? Yes, Brianna?
So only for the angle angles when you do the cross multiply.
No, you could do cross multiplying for other things, but angle is just proving that they're similar so that I can set up the proportions. So you have to prove they're similar proportions. But you could have done that by side angle side or side side side.
Okay.
Alright. How do I know these two triangles are similar? Because of what? They've got these two angles in common and what other angle?
The dining right there, yes, because they're 2 over.
Right, because they're in. So I'm angle again. So I've got 7 over what?
35.
25. 8.
7 and 28 is
35.
35. I had to do the whole length.
Oh.
Over h over 25. That is a crazy looking h I just drew, but that is an h. 7 times 25 gives us 175 equals 35h. Divided by 35. So we get h equals 5.
Wait. Where did you see 35 at?
7 plus 28.
Oh, you right. I'm sorry.
Because 28 would not be the whole length of the triangle, right?
Yeah, you're right.
Alright, let's do the lovely little story problem. That the picture doesn't show up. To determine the height of a pine tree, place a mirror on the ground and stand where you can see the top of the tree shown. How tall is the tree? I've actually done this before. It's kind of cool. Okay. So, how tall are you in this picture?
Oh, 6 foot.
6 foot. We're really tall. How tall is the tree?
24 feet tall.
How tall is the tree?
Oh, 24 feet tall. It doesn't say.
Right.
24 feet tall.
How far are you from the mirror?
24 feet. 2 feet.
How far away is the tree, Chris?
24 feet.
There, that's when you use the 24. Okay, so we get 2x equals 6 times 24, which is 144. Divide both sides by 2. And the tree is 72 feet tall.
Yeah.
And it's actually
That's a huge tree.
And this is important to know things like that if you're buying property or selling property. Sometimes they want to know how tall the trees are on your property. And I was like, why would they want to know that? It's a great selling point in some communities to say that you have really old trees. And then you want to say how tall the tree is to say how old it is. Or some places they're like, you can't build a fence if you have a tree this tall because then the tree could fall on your neighbor's property and hurt their fence and blah, 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 blah. And so I've actually done this. You put a mirror down, you step back until you see the top of the tree in the mirror, and then you measure the distance between you and the mirror, and then measure the distance between the mirror and the tree, and you can figure out how tall the tree is. Because let me tell you, I did not have a 72-foot ladder to measure that tree, nor do I have a tape measure that's 72 feet long.
There's a 26-foot tree.
Okay. Thank you.
We're recording that.